Hi and good morning, everyone. So today we'll be discussing on two questions, okay, from page 194. Okay, you can refer to your textbook. We'll be discussing on question number 2 and question number 4. Okay, so let's have a look. So question number 2 here, the incomplete distance time graph shows Encik Jumali's journey for a distance of 100 kilometer. Okay, so this is the graph. So the graph here, we have distance in kilometer, okay, and we have the time in minutes. It is given that the rate of change in distance for the first 60 kilometers is 72 kilometer per hour. Calculate the value of T1. So question number 2A is telling us about the rate of change in distance. This is referring to speed. Okay, so speed for the first 60 kilometer is 72 kilometer per hour. Okay, which is from O to A. And we need to find the value of T. Right. Then let's look at B. If Encik Jumali's car is stationary for 20 minutes, calculate the value of T2. So after we find the value of T, okay, we know that Encik Jumali's car is stationary. Okay, stationary means it's not moving for 20 minutes. Then we can find the T2. Okay, T1 plus with 20 minutes to find T2. His journey continues from B to its destination with an average speed of 75 km per hour. Complete the distance time graph for the whole journey of Encik Jumali. So for question C, all you need to do is complete the graph from B to the destination. Okay, so for the C part, we need to be using a ruler. Okay, make sure it is exactly at 100. And then last question. If the journey from O starts at 9:30 in the morning, calculate the time Encik Jumali arrived at his destination. So if Encik Jumali begin his journey at 9:30, so what time does he arrive? So we need to find all the answers of this question. Okay, so here is a drawn version of the graph. Okay, so let's have a look. So again, question number 2A, we are given that the rate of change in distance for the first 60 km is 72 km per hour. Calculate the value of T1. So remember, T1 is in minutes, whereas the rate of change of distance given is in hour. So when we calculate later, we must divide T1 with 60. Okay, so let's do this together. Okay, so firstly, rate of change of distance is equal to speed. Okay, and speed is equal to distance over time. Okay, I hope you still remember. Now the rate of change of distance given in the question is 72 km per hour. Okay, and then the distance, okay, the rate of change of speed or the rate of change of distance for the first 60 kilometer. Okay, so that our distance is 60 kilometer, and time, so the first 60 kilometer, the time is T1. Okay, T1. And since it is in minutes, okay, and our unit here is in kilometer per hour, so T1 divide with 60 to change to hour. Okay, sorry ya, gegar sikit. Okay, so here is 72. Right, so this will switch places. Right, so T1 over 60, move here, and then 72, move down here. So 60 divide with 72. After that, we want to find T1 only, so divide 60, move to the other side, becomes multiply 60. Okay, so T1, you get your answer in minutes. Okay, so make sure you press your calculator for this one. Okay, and you should get your answer. Let's see, 50 minutes. Okay, 50 minutes. Now this is for the T1. Now, okay, now for question B, if Encik Jumali's car is stationary for 20 minutes, calculate the value of T2. Okay, so meaning to say, if the car is stationary, so stationary is from here to here, right? So if the car is stationary for 20 minutes, what is T2? So 50 plus 20, T2 is 70. Okay, so this is the answer for B. Okay, and this is the answer for A. Okay, and then question number C. His journey continues from B to its destination with an average speed of 75 km per hour. Complete the distance time graph for the whole journey of Encik Jumali's. Okay, so now we need to complete the graph, right? So this is our 100 kilometer. And then you just draw a straight line from here to up here. Okay, so it doesn't matter because we don't know the time here yet, so you can just put it wherever. Okay, as long as it reaches the 100 meter. Okay, make sure it does not exceed because that is the destination. Okay, so from here to up here, done. Okay, right, so I'll just draw a dashed line down here. Okay, but we don't know the number here yet. Okay, still a mystery. But our question tells us a very important information. It tells us that the average speed, okay, from B to the destination is 75 km per hour. We have the average speed for this part. So if we have the average speed and we have the distance, can we find the time taken? Of course we can, right? So let's try to do this. So I'll put the time here, okay, when Encik Jumali arrived as T3, okay, because we don't know it yet, so I'm just gonna put it T3, and then just write down based on our information. Okay, we have the average speed. Okay, average speed, remember the formula, it's equals to total distance traveled over total time taken. Now, average speed based on the question just now is 75 kilometer per hour. So just rewrite that, 75 kilometer per hour. And then the total distance, it's talking about the distance from here to the destination. So from here to here, what's the distance? 100 minus 60 equals to 40. Okay, 40 kilometer. And then time. So total time, we don't know. Okay, but we know that the time here would be T3 minus 70. Okay, T3 minus 70. So T3 minus 70 over 60. Okay, again, why over 60? Because the unit here is in minutes. Okay, and here we have in hour. Right, so for this one, we just swap places. So T3 minus 70 divide with 60, move here. And then 75, move down here. So become 40 over 75. And then remove one by one until we are only left with T3. So T3 minus 70 divide 60, move here becomes multiply 60. So 40 divide 75 multiply 60. And then minus 70 move to the other side becomes plus 70. So T3 only, 40 over 75 times 60 plus 70. And you get your T3 in minutes. Oops, in minutes. Okay, so everyone, please press your calculator and give this a try. What's your answer? Okay, so you get your answer 102 minutes. Okay, so we can substitute inside our graph. T3 is equal to 102. Okay, good. Now, last question. Question D. If the journey from O starts at 9:30 in the morning, calculate the time Encik Jumali arrive at the destination. So it's telling us that he starts his journey at 9:30. So what time does he arrive here? Okay, 9:30 a.m. Okay, so what time does he arrive here? So all we need to do is just 9:30 plus 102 minutes. Okay, and 102 minutes is coming from 60 plus with 40, right? 42. So 60 is 1 hour. This is 42 minutes. Okay, 9:30 plus 1 hour, 10:30. 10:30 plus 42. So Encik Jumali will arrive at 11:12 a.m. Okay, so that is the final answer for question number 2.